Right. On this question, we want to approximate the area under the curve over the given interval using 4 inscribed rectangles. The curve we're working with is y equals -x plus 5, and we want to find the area under that curve on the interval from -7 to -5. Now, of course, we're approximating the area. We're not finding the actual area. We're approximating the area with 4 inscribed rectangles. If we were finding the actual area, we'd be using our definite integral. But this question is from before we learned about the definite integral. And so we're going to use this approximation technique to find the approximate area under the curve. So let's start by drawing a picture. We have the equation y equals -x plus 5. This is a straight line with a y-intercept at 5 and a slope of -1. So it has a y-intercept at 5. We go down 1 and over 1 since it has a slope of -1. We can connect those 2 points with a straight line since this is a linear equation. And we're trying to find the area. My scale is not so great here, but we're trying to find the area. We're going to estimate that this is -7 and -5. And this is the area that we're interested in finding. So we are going to first develop, well, let's write down the formula for this area under the curve. Well, really area of the rectangles. So that's the sum of I equals 1 to n f of ci times delta x. And this formula, let's break down what the different parts are. We have n. N is the number of rectangles. Delta x, we're going to try to keep this simple by making our rectangles equal width. And this delta x represents the width of each of our rectangles. Ci is going to either represent the left endpoints or the right endpoints, but we need to think about which rectangle would, which endpoint would give us an inscribed or a rectangle that is inside. So to figure that out, we would draw what we call a sample strip. So I'm going to draw a sample rectangle that lies within our interval and think about if we use the left-hand side to mark the height, that rectangle would be outside of the curve, outside of the graph. However, if we used the right endpoint, the rectangle would be inside the curve or inscribed. So because of that, I know that CI is going to be the sequence of right endpoints. And then f of CI, f of something is the y value, and that is going to mark the height of these rectangles. So this is the height of the rectangle. So we have some work to do in designating what actual values go with these formulas. So for n number of rectangles, we have 4 rectangles. Delta x, the width of the interval, we have a formula for that, and that is b minus a over n. The interval given is -7, -5, and those are our a and b. So that's going to be -5 minus -7 over 4. -5 minus -7 is -5 plus 7 over 4. That's 2 over 4, which is 1/2. Our delta x is 1/2. Then our right endpoints, we have a formula for right endpoints, and that is a, the beginning of the interval, plus delta xi. A is -7. Delta x we have to be 1/2. So we have our sequence of right endpoints being -7 plus 1/2 I. So then we need to find f of ci. F of ci is substituting that sequence that we just came up with into our function. Our function, I've kind of covered it up here, but is y equals -x plus 5. So in for x, we substitute -7 plus 1/2 I. And we have +7 minus 1/2 I plus 5, which is 12 minus 1/2 I. Our f of ci is 12 minus 1/2 I. Okay, now that we've identified a bunch of pieces from this formula is going to give us the area of the rectangles. We can now substitute what we figured out into that formula and start simplifying it. So we're starting with the sum of I equals 1 to n, f of ci delta x, and n we didn't find it, it was given to us that we wanted to approximate with 4 rectangles. So we're going to do the sum of I equals 1 to 4. F of ci we just worked out to be this right here. That's 12 minus 1/2 I. And then we also need to substitute in delta x, which is 1/2. I'll use the distributive property. That's the sum of I equals 1 to 4. And I'll distribute that 1/2 to both of these terms. 12 times 1/2 is 6. And 1/2 I times 1/2 would be 1/4 I. So we're finding the sum of this expression. We can sum the individual terms. We have the sum of I equals 1 to 4 of 6 minus the sum of I equals 1 to 4 of I. I'm going to take that 1/4 and factor it out of the sum. And there are multiple ways for you to get this answer. Having an n being 4 means that it's not too hard to actually find this sum without any formulas. This first one, you just need to add 6 4 times. And the second one, you would plug in a 1 in for I, then plug in a 2 for I, then plug in a 3 for I, and then a 4 and add them up. However, I'm going to use our summation formulas. Sum of a constant is that constant times n, and then sum of I is n times n plus 1 over 2. So that's 4 times 5 over 2. So we have 24 minus 1/2 times 20 over 2. 24 minus 20 over 4 is 24 minus 5, and we have 19. All right, so someone who's paying attention better than I was noticed that I changed that 1/4 to a 1/2 here, so I need to make that correction. I'm just going to highlight the changes I'm going to make so that I can correct them. So if I carry down that 1/4 instead of my wrong 1/2, that would be 1/4. And then I would have a 1/4 right here. And that would make this right here 20 over 8 instead. And 20 over 8 would reduce down to 5 over 2. That's 2.5. We have 24 minus 2.5, which is 21.5. So the area of 4 inscribed rectangles for our equation y equals negative x plus 5 on the interval from -7 to -5 is 21.5. Thank you for checking out my videos. Have a great day.